now. All right, Kennedy, here's your help. This is taking too long for me to do this for you. I'm sorry. In this one, we have to find that first. That's what I've deduced. So we could say a squared is b squared plus c squared minus 2bc cosine of a. Now, why did I pick that? Well, because I'm going to need all of the sides to find the missing angle, I think I'm going to. And here I have everything else other than a. So look, a squared is 4.2 squared. Remember that the side is across from the angle. So 4.2 squared plus 5.7 squared minus 2 times 4.2 times 5.7 times cosine of 120. See, that's why I picked that one. Now I just got to put all that in my calculator. Okay, so you get a squared is 74.07. Okay, so then we square root that, and you get a is 8.606. All right. So now to find b, we want our b to be capital, so we'll do b squared equals a squared plus c squared minus 2ac cosine of b. All right. Why did I choose that one? Because this is the angle we're looking for, and we now know everything else. So it'll be 4.2 squared equals, what did we get? 8.6 squared plus 5.7 squared minus 2 times 8.6 times 5.7 times cosine of b. I'm going to have to erase this for a sec. Sorry. Well, if you want to see it, just go back and watch the video. All right, so how can I do most of this? So cosine of b equals, all right, so what I have to do is subtract all this and then divide by that, okay? So I'm going to do all that in one step on my calculator. 4.2 squared minus 8.6 squared minus 5.7 squared equals. And then so I get a negative 88.81, and then I divide by, parentheses, negative 2 times 8.6 times 5.7, and you end up getting 0.9058. How do I get rid of cosine? Cosine inverse. And you get b is 25 degrees or so. It's 25.0. And c then is the rest. So it's 180 minus 120 minus 25, and you get 35 for c. All right, next. That one was hard. That one's easy. To the nearest tenth, what is the area of the triangle? Okay, this one won't take nearly as long. How do I find the area of the triangle? 1/2 base times height. So I need to find the height. Well, how do I find the height? Well, according to the 41, the height is the opposite, and 18 is the hypotenuse. So sine of 41 is, we'll call that h over 18. So h is 18 times the sine of 41. So h is 11.809, and that makes sense. So the area of the triangle is 1/2 times 28 times 11.809. And you get 165.33 square units. Gotta keep my units. Determine two angles that are coterminal with negative 4 pi over 3. Well, the quick way to do this is just, coterminal means they end at the same spot. So all we have to do is add and subtract 360. But this is in radians, so we will add and subtract 2 pi. That's how you do this. So you get negative 4 pi over 3 plus 2 pi. Negative 4 pi over 3 minus 2 pi. Now, you could also have added 4 pi if you wanted, like add 720 degrees. So what do you get for this? Well, that's negative 4 pi over 3 plus 6 pi over 3. So that's 2 pi over 3. And then you get negative 4 pi over 3 minus 6 pi over 3. And that's negative 10 pi over 3. So there's 2. There are infinitely many answers, though. If you check the key and you get different ones, that might be why. So what is the value of theta in radians? Okay. So cosecant of theta is negative 1.124. All right, we don't have like an inverse cosecant button, but I know that means 1 over the sine of theta. That's what cosecant is negative 1.124 over 1. Oh, so what does that mean? Sine of theta, just flip both sides, is 1 divided by negative 1.124. Now, we can take the sine inverse of both sides. So it's sine inverse of negative. First, let me change my calculator into radians, because that's what it wants. Okay? And now I just do second sine. It gives me the parentheses. 1 divided by negative 1.124. Close the parentheses. And you get theta. Theta is negative 1.096. Okay. Next, that's in radians. The pepperoni sector of a pizza has an area of 24 square inches, pi square inches. So we have a circle, and then whoever made this weird is like, well, we'll put pepperoni on this part. So the area of this is 24 pi. What they want to know is, what's the angle? And if the radius is 8. Okay, so they want to know, well, I don't know. How do I want to show you this? What's the area of a circle with a radius 8? Well, that's pi times 8 squared. 8 times 8 is 64. So here's really what they want to know. 24 pi is what fraction of 64 pi? And then here's how I would do it. 24 pi is to 64 pi. Excuse me. This is to 64 pi. Like x degrees is to 360 degrees. Does that make sense? Now the pi's cancel, so we don't need those. So you get 64x is 360 times 24. Divide each side by 64. And that's what x is. 360 times 24 divided by 64. And you get theta is 135 degrees. If they want it in radians, nope, they say in degrees. The platform of a merry-go-round is 14 inches to 9. How much is the person standing on it? All right, so you got top view, 14 meter diameter, It's spinning at 7 revolutions per 1 minute. It wants our answer, how fast in meters per minute. Meters per minute. Who gives that? Meters per minute. Okay. So we have revolutions per minute. We need to turn it into meters per minute. So, well, let's see. This is called factor labeling. 1 revolution. See, look, that's going to cancel the revolutions. Well, how far do we go in 1 revolution? Well, that's 14 pi meters. That's how long a full circumference of a circle is, right? Circumference is pi d. All right, so now we are in, oh, shut up. We're in meters per minute. That's all we had to do. And now you just multiply across, and the answer will be 7 times 14 times pi divided by 1. I can't believe that was that quick. I feel smart for once. And you end up getting, so you see how this is meters per minute? That means we're good, because we canceled the revolutions. Not prints in the revolutions. You can't cancel them. 8 meters per minute. However fast that is. All right, last one. Find the measure of the angle between 2 forces of 40 pounds and 50 pounds if the magnitude of the result... Okay, so here's what's going on. You have a single object, okay? We're pulling... Find the measure of the angle between 2 forces. Okay, so the object, will say, the center of that object is at the origin of our axis. We can do it however we want. So now, one of these is pulling 50 pounds. Now, in order for me to draw this picture right, look, if I pulled 50 pounds in this direction, and then 50 pounds in this direction, sorry, 50, the force exerted on that point would be 0. So that means that at least some of these are going in the same direction, okay? Alright, so this is the angle between them. That's what we're trying to find. So if we did 40 times I think this is a good idea. Let's just let the blue angle be right there at 0. Cosine 0, sine 0. That gives us the vector form of that blue vector. Now the other one is going to be 50 times cosine theta. We don't know. Sine of the same angle theta. Okay? That's going to be the black one. Now if we add the blue one and the black one and take the magnitude of it, it should give us 68. So, let's see. Cosine of 0 is 1, so the blue one you end up getting 40, 1, or 0. Excuse me. Plus 50 cosine theta sine theta. And if we take the magnitude of that, that should equal 68. I don't know if this is going to work or not. So 68 is the square root of, when you add vectors, you add up these. So that's 40 plus 50 cosine of theta squared, and then plus 50 sine of theta squared. Okay? So let's square both sides to start. So you get 4624 equals, let's see, when we square this, you get I gotta write this out. So you get, let's see, 40 times 40 is 1600 plus 4 times 5 is 20 to 2. So plus 2, this will be 2000 cosine theta plus 2000, so that's plus 4000 cosine theta. I'm literally just foiling here. Plus 250, nope, 2500 cosine squared theta. Yep. Okay. Subtract the 1600 from both sides. No, we want to get it all on the one side. Kennedy, I'm going to send you this video now, and I'll redo this last one. We just need to solve this thing for theta, but I honestly have to go get my kids from school. But this is a good start. This is 5 of your 6 questions. I'll see you tomorrow. Boom!